Hello again, everyone. Welcome to this new training session organized by Tunis R User Group. This is the second meetup that you organized, so you are active since a few months. This is our team. I'm Mone Belaid, so I'm basically engineering statistics, and I'm currently working as a business intelligence at Prime Analytics. I was pleased to start this new group with Amalet Lili, who's a data science engineer, and Hidyat Nani, who's a postdoctoral fellow at Pasteur Institute of Tunis. So you aim mainly to provide a friendly support network for R lovers in Tunisia and also worldwide. You are a group of women who love programming with R. And so this is a volunteer-run organization. You are part of a global community, so there are many R user communities worldwide. You can see so more than 800 groups worldwide, so across many regions. Okay, so you have a code of conduct. So please, let's just make this place so as welcoming as possible, and let's make just a friendly community for everyone. Yes, so you have recently started working on a new series. This is the one package per meetup series, and the objective is to be hosting an R expert who has done many great work about one package to come and to present this package, to present updates, maybe the main functionalities. And first, so we'll be focusing on one theme. This is the data visualization one. So that's why. So today you are pleased first to host Mitchell Hora White. And he will animate workshop about the Gganimate R package. So let me just introduce our invited trainer. He's a data science developer, consultant, educator, and he's also the lead developer of many R packages that I invite you to have a look at them, like the Tidy Time series and forecasting package Fable and R Markdown CV writing package every day. Okay, so teach data and many data analysis, so courses and research at the Monash University in Australia. This is just an overview of our planned workshop that we'll aim to organize during the next 4 months. Next, we'll be pleased to host Zainab Giwa, who's the data analyst at Invisible Institute, and she's also the organizer at R-Ladies Chicago. She will animate a workshop about the R2 D3R package. So we are pleased to host Dean Italy, who's an R-Shiny expert and an open source developer. He will present to us about the color pickle R package. So we'll work with this package for Shiny application to pick up the colors. I think that would be so interesting. Last, we'll be pleased to host Thomas Lynn Pedersen, who's a software engineer at R Studio, and he will animate a workshop about the tidy graph R package. So just for information, if someone has another suggestion, if you would like, so for us to animate a workshop about one, just tell us about this package. We will be pleased to do this. Before we start, so as I said, we plan to record the workshop today. So please, if you prefer not to be recorded, just turn off your video. If you have questions, please just use the raise your hand feature in Zoom and leave your message in the chat. And last, you have a short feedback form at the end of this workshop. So just please fill out this form that will allow us to better serve you in the next meetups. Thank you all for attention, and the screen is yours, Mitchell.
We'll be launching the first poll. So
okay, let me share the screen and we'll get started. No need to fill out the form just yet.
Okay.
There'll be an opportunity for that. Okay, I can stop my video, so hopefully you see me on a big screen. Hello everyone. Very amazing to see so many people here today. I think there's still a few in the waiting room, if they can be admitted in. But it's a pleasure for me to be here and introduce a package that I've used a few times before in my teaching, that is Gganimate. So I've put together some slides here that we'll go through, and the format of this, it's not going to be like a lecture. I hope for this to be more of an interactive discussion. There'll be lots of opportunities to fill out polls, as many of you are already doing. And hopefully, if you've come along with a plot that you would like to animate, there'll be some opportunity at the end to try out the animations while I'm around, and we can help each other trying to make the animations that you want. The slides are available. Here is the link. I've just put them up, so hopefully you'll be able to access them. I have copied that into the chat to make that a bit easier for you to access. Let's get started. So hello everyone, this is me, I'm Mitch. You can simply call me Mitch, and you can access my socials at the top here. And I'm from Melbourne in Australia, and it's very late right now. It is just past 4:10 in the morning, and I have not slept yet. No link coming through. I'll give that a minute. It is a fairly large slide deck, so it might take some time to load. But it is 4, so I promise I won't fall asleep, but there's no promises that I won't yawn, but I'll do my best. So I teach R data skills. This semester I'm teaching communicating with data at Monash University, but a lot of my time is spent doing data science consulting with my consulting company Nectric, and I do a lot of time series analysis. So most of my work is centered around the R package I've made called Fable, which is for tidy time series forecasting. It integrates well with the tidyverse if you need to do some tidy time series analysis. You may have also seen my work through the Vitai package or the icons package. Outside of data science, I love permaculture. I've got some bees and chickens, as the picture suggests, and I try to integrate it a little bit. So I've got some sensors that I do some data analysis on them with. Okay, so here's some of you, and I want to start by looking at this poll that I've been running and find out a little bit about you all. So who are you? If you haven't already, open up the polls in Zoom, and there's a few questions that I prepared for you. So the first is, what kind of person are you? Do you like your base R? Do you prefer tidy R? Or either or both? Do you use whatever is most appropriate for the task that you're trying to achieve? I'll give you a moment to fill that one out and see what we get.
Yeah, so we have 31 of 35. 88% of people already responded to the poll.
Okay, so here's the answers, the results that I see so far. Looks like most of you are similar to me. I kind of prefer tidy R personally, but if there's a package that's got a base R style, I'm not gonna avoid using it. I'll use whatever tool is required to get the job done. A lot of you have used ggplot2 before. It actually looks like there's 2 options here, so most of you have used it before, if that's the case. So that's great to hear, because I am going to assume that there's some ggplot2 capabilities. We're not going to cover much about ggplot2, and we'll instead focus on animation with Gganimate. And perfect, it looks like we've got exactly who I was hoping to have in this workshop. Many of you are first-time Gganimate users, and a couple have tried it out before a couple of times, but might benefit from a more detailed description or workshop that we'll cover today. I put this option at the end here. I made ggpacman expert because the person that made ggpacman said that they were attending, and I would like to point out this absolutely amazing, insane piece of work that he's put together, just to give you an idea of what's possible with Gganimate. So I hope we're all familiar with Pacman, And I couldn't believe that something like this is possible with Gganimate. And if you read through this blog post that I'll copy into the chat, you can see just how much work is put into animating each individual tile on the grid. But not only that, but Pac-Man itself can be made with code, with data, and animated with Gganimate. And then he goes on to do the baddies as well. So he's drawing the ghosts. So if that's not motivation for animation that can do anything, if you are persistent, you can do whatever you like with it. Okay, thank you for filling out the polls. There'll be more coming up. So today in this workshop, I'd like to talk about a few things. I hope that you can all take away an animated plot of your own. I hope that you gain a better understanding about why or when an animated plot is useful. We'll talk a little bit about the continuum between engagement of a static plot that you probably have all made before, an animated plot that we'll be talking about today, and an interactive plot that is more commonly made, and try to justify the in-between in terms of engagement and encourage you to try out making animated plots. So I'll run through a couple of demos as well, and at the end we'll try Gganimate for ourselves. As mentioned, I really want everyone to take part in the discussion, so feel free to put your hand up with the little emoji. You can type your opinions in the chat and fill out the polls. I don't mind if people unmute if you don't mind being recorded, but just raise your hand first. Okay, so let's talk about the three types of plotting and interactivity, the continuum that I mentioned. And I'm going to start with some examples from my own time series work. So this is mainly from my, my teaching and also some talks that I've given. So here's an example of a static time series plot, and this is half-hourly data over 3 years. And the exact details of what patterns and the interesting part of the data isn't so important here, but the idea is that there's too much detail for us to see what's happening every half hour. So we might want to zoom in on this plot to get a better sense of what happens each day. So if with a static plot, I might just go straight to the next plot that we have. And here I can see the daily pattern, where overnight there's low demand, and during the day there's this multiple peak pattern corresponding to the working hours, the 9 to 5. But there's no real context for what this time period is. So when I'm giving a talk, I often like to use an animation. So starting from a very similar view of the data, I can then animate into that same time point, and you immediately get a sense from the large complete data set exactly where we're looking now. The alternative to this on that continuum is the interactive graphic, and this requires the user to look around for themselves, zoom in a little bit, and identify the patterns on their own. Now this has its value, especially if you're an owner of the data or if you're trying to investigate it yourself, rather than being told a story. However, it does require additional effort and skills. And in addition to, if I was presenting this in a slide or on a stage or something, there's that added layer of complexity for having to drag around while talking, find exactly what you wanted to show. It's a lot more work and a lot more difficult to demonstrate your story with an interactive graph in some circumstances. Here's the second example, time series example that I have for you. This is about a transformation that we commonly do with forecasting. You can see the seasonality, that's the up and down pattern, is growing in size towards the end. And this makes it a difficult pattern to forecast. So one thing we do is transform the data with what is known as a Box-Cox transformation in order to flatten out this pattern. And you can see the log transformation on the right has done a good job of this. So all those peaks are roughly the same size now, which will be easier to forecast. Now, a static graph here works okay, in my opinion. It shows a bit of a continuum across the three plots, and we can identify what is most appropriate. If I were to animate this, I might choose all different types of the possible parameter from 0 to 1. And this gives a more smooth representation of how this parameter changes the shape of the data, changes the shape of the curve. An interactive alternative, if I reload the Shiny app, might give you the option with a slider to choose what parameter you prefer and see what value you get. And I've used all three of these in various applications. I had a poll for this one. I'm not sure if that's ready yet. If we could move on to the next poll, if that's ready. I wanted to ask your opinion. Which of these three types of plots would you think is most useful for understanding the Box-Cox transformation? Do you prefer to see the three plots with facets in a static representation? See the entire display with a smooth animation? Or being able to interact with it on your own? Maybe I could end the poll, the original poll. Okay, I'm not sure if that one's quite ready yet.
No, it's not yet ready. It's not.
Okay, let me see if I can put this one in. I don't have permission to change it. That's okay. You can put your opinions in the chat, and we'll try to get the next set of polls ready. So I see two people suggesting the interactive one. Everyone seems to think interactive is the way to go. So that's an interesting choice. One person suggesting the animated one. I like your thinking, maybe because we're in an animated talk. Animation with Shiny, that's an interesting suggestion as well. So when you've got a continuum, the interactive graph that I'm showing here now allows you to also have a play button. There's nothing stopping you from making this a semi-interactive plot, which allows you to click onto an animation step as well. So that's probably the best of both worlds here. But I've actually used all three of these plot types in different circumstances. So to go back and talk through some of these, the static one is a good application for a static report. If you need to prepare something for a paper or need to print it out as exercises, or otherwise need to share it in some place that doesn't allow for animations, this static plot achieves all of the necessary data exploration and data story that I needed to convey. We have some original data with a problem, we start making some transformations, which wasn't enough, and we've find the appropriate transformation that we needed. So this is sufficient. The animated one is better for when I'm giving a talk. So I don't have to really focus on what I'm zooming on now, and I can just run the animation. And this interactive graph actually appears in our textbook, which is appropriate for self-directed learning. So as our students read through the textbook, learn about transformations, we let them play around with the slider for themselves. Yeah, exactly. Different options work best under different learning situations and also different contexts for the presenter. So there's some examples that I've put together. I wanted to also look at some examples that are available on the web. So if you're a data scientist, you may have seen these types of groups around that really love to see some plots. So I wanted to look at the animations, or just what plots are the top rated of all time. So here it is here. And you can see number one, we've got some form of animation. And you can think to yourself, is this a good animation? Does it actually help you understand what's happening in Google searches across America over time? Or is it just very entertaining to look at because the colors blink around a lot? Regardless of why, what makes this a good or a bad graph, it's certainly very popular. So you have to kind of think about balancing engagement as well. Certainly moving images helps spread your story a little bit further. So it's kind of telling that the all-time highest ranked beautiful data on this website is an animated graph. I would also like to point out with this plot everyone knows how to read a map. So this is a quite accessible data set, quite accessible visualization to demonstrate quite a complicated topic. Here we've got search terms over time. So being able to visualize it in this way is making this information more accessible, even if it isn't as precise as we would expect as a data scientist. Okay, we've got an ad. Let's skip past there. Here's a static graph. The next one here is an animation. It's a bit of a joke animation for this, the flu. This is referencing another graph that they made earlier after removing the Spanish flu to actually make it useful. One thing they could have done here is use a log transformation on the axes instead. Okay, scrolling a bit further down, you see a very different type of animation here. But overall, you can see that there's quite a few animations that are highly ranked. So if that's not justification for needing to learn animation or finding value in producing animations, then I don't know what else would be. Okay, so here's some summary that I put together. How can animation help us tell our data stories? The first point, especially evident in the map that we saw, it allows simple graphics to show changes over time. So all of the ones that I saw highest ranked on that subreddit was relating to the time variable. And I find in my work with time series, being able to communicate about things over time is really difficult for people that aren't trained in time series. It's a bit of an abstract concept where people don't really work with the fourth dimension of time very often. And as soon as you make a line with the x-axis of time, unless they're familiar with looking at those charts, it can become really hard to follow. I also use animation to show more detailed steps. This example is the box-cox transformation. Instead of just showing those 3 points with the transformation, we can show every point in between. And lastly here, I also think it's useful for guiding the exploration. So not being required to click through the interactive graph while you're giving a talk can help you focus on what you're saying and the message that you're delivering. And lastly, I think the main thing for why it's highly ranked on the subreddit is that it really grabs your attention. So if you're scrolling through a bunch of stuff, a bunch of plots or figures, and something moves, it's going to get your attention. So I use this a lot for my students when they're not paying attention. That said, animation can be very tricky as well. It's very easy to make a good plot bad by adding animation. And I've summarized 3 main problems that I see in animations. The first is the pace. So some people might make their animations go too slowly and it gets really boring to watch and you give up halfway through. Other people might make it too quick and you can't see what's going on. The next would be perplexity. So often with static plots, we have this desire to kind of put as much information as we possibly can into the plot. And I think this is a problem. So what I try to do when I visualize data is to produce the simplest possible graphic, the least amount of information or the least amount of content on it in order to answer the question correctly. And this also applies to animations. If you take your very complicated static plot and then add a layer of animation on top of it because you want to see what it does over time, it's going to be really hard to digest. It's going to be really hard to remember what happened just 2 steps ago while you're trying to also figure out what's happening in the current frame of the animation. And lastly, I see a lot of people just putting in animation for the sake of it, and it doesn't really help providing any additional information that you wouldn't get on top of your static plot. And I've got an example of this as well. Okay, so if you've come along with a plot or have thought about an animation that you've tried to make before, have a think about what type of plot was most appropriate for the data. Should you have kept with the static plot, or would an animated plot work best, or interactive plotting? And it may not be just one of these. It may depend on the circumstance for when you're telling this data story. Any thoughts that you might have, you can put in the chat. You can maybe describe the animation you were planning to make. We've got plenty of time today. Yeah, one suggestion is animated maps. There's many different ways that you can animate a map. I forget the word, I think it's a choropleth, where you distort the map in order to show the total amount of things in that area. And that can also be animated. It's quite a difficult thing to think about when a shape is morphing into different shapes. But the other animated map that I see people do is just zooming around to different locations. So the example that Thomas gave, the author of the Gganimate package, when he was introducing it, was his travel to make it to the conference. He showed himself in Europe, flying over to Australia via Singapore. So that helps tell the story a little bit better than just giving an overall map. Okay, this is a good question. It's really suggesting what's going to come up next. Do you have any examples of times where you'd prefer to use multiple facets instead of animation when dealing with time series data? So I've got an example where I would prefer multiple facets instead of an animation, not for time series data, but certainly one animation that I see people do is take a time series line and try and morph it into other lines. There's an animation a bit later that I can show you of this as well. And I find that one quite distorting, especially when there's no relevance between the two lines that you're merging together. I think when animating, there should be a strong relationship between the things that you're morphing into each other. So if they're completely separate time series, or if they can't reasonably be connected with a continuous fluid animation, I would do multiple facets. And you can do animations within each facet as well, if there were related things that you wanted to animate across those facets. Okay, I've got a couple of other questions in here. Does this choice of static, animated, or interactive change based on your audience or the context of the talk that you're giving? And I think we've touched on this a bit already. I think it's certainly the case that interactive plotting is very suitable for self-directed exploration, whereas animated graphics really force you into a single story. So it really is more suitable to a linear exploration, like a presentation, like a talk, the very linear way that you want to describe the data. And how does animation help you tell your data story? Well, it can add that extra layer of information. So especially with the time variable that I see a lot of people using, it helps people understand how things are evolving over time for people less familiar with working with plots. They maybe only see bar charts. Actually, going back to the idea of bar charts, I wanted to go back to one of these plots. I think I skipped over it. Maybe it's a little bit further down. There's a very popular type of plot. This is the one I was comparing against before, where it's a bar chart. Most people understand a bar chart. It's very simple, bigger bar, bigger number. But converting this bar chart into a time series plot suddenly you need to compare multiple lines because the x-axis becomes time. And pretty quickly, if you're comparing, I think there's 10 different outbreaks here, it looks like spaghetti. You've got 10 lines on top of each other. The uninformed data scientist, sorry, the general population, I should say, who is less familiar at looking at data, let alone a line plot, would have a much harder time looking and interpreting that data. But putting it in an animated bar chart over time is a lot more entertaining. And therefore, it's a lot more engaging, and people can really understand the scale of the COVID-19 outbreak with this comparison. And yes, animation is definitely a goldmine for tweets. Anything that moves on Twitter will get you some likes and retweets. All right, let's move on. So now we've talked about why and when you should be using animated or interactive or static graphs. Let's see about how we might do that. So one thing that you can really think about here, each of these figures that I've put in, each of these background pictures, have some relation to animation. So there's a bit of a secret game you can play here. What kind of animation are we showing with this picture? So this is a beautiful illustration by Alison about ggplot2 making some art. And I'm hoping, at least from the poll, that everyone has a little bit of practice and experience with ggplot2. Because ggplot2 is the foundation for everything that we'll build our animations with. And if you don't have a good ggplot2 plot, then you won't be able to make an animation on top of it using Gganimate. So the basics of ggplot2, we won't spend a lot of time on this, is that you need a dataset. Usually this dataset will be in a long format, and that means each row is an observation and each column is a variable that you might map to a given aesthetic, like the x-axis, the y-axis, the color, or even with Gganimate, the scene or the state that you'll animate between. So that might be the time variable. You need a way to map the data variables onto the axes. So what column of the data, what variable goes onto the x-axis, which one is the color aesthetic. And lastly, you need some graphic, some geometry to display that mapping. So you might use a line or a point. There's also a few other things that I couldn't leave out without being in some strife from my visualization professors. So I put them in here, but this isn't a grammar of graphics workshop. We're talking about animation here. So the big topic, the extension of ggplot2, Gganimate. So before we talk about Gganimate, I wanted to give a very quick history of Gganimate because it has changed a decent amount since David Robertson first created it. The first version of Gganimate that was created by David was a very simple approach. It added a new aesthetic to Gganimate. And by simple, I mean relative to the magic that Thomas Lynn Peterson has done with the package since. So David added a frame aesthetic. So just like you added the x-axis or the color, he added the option to specify the frame. And when you created the plot, each frame would be a separate static plot, just combined together. Now, then Thomas came along and rewrote it completely with the help of some tweening and a new grammar to describe, so I'll get out of the way of this text, with a grammar to describe the tweening or the animation that you're adding to this. And the neat thing between these two implementations and the rewrite is that no longer do you have to do the tweening yourself, but you automatically get a smooth transition between each of the states. That's computed for you using the tweenr package that Gganimate now uses. So you can really focus on each of the separate states that you want to display, and you don't have to worry about how the animation works. So once again, here's Alison's beautiful artwork on Gganimate. You can see all sorts of fireworks and movement happening. It's a lot of fun to make some animations. So the grammar, I think Thomas avoids to use the term grammar, but it acts very similar to the grammar that ggplot2 has created or implements. And the main element of the grammar of animation is transitions. So just like you would add a geom to your ggplot, here you add a transition to describe how your data will move throughout the animation. So perhaps you're transitioning from the year 2000 into the year 2001. So your transition will describe how that variable is used to change the variables of the plot. That's the main one that we'll be using. The view is one that can be used on its own as well. This essentially defines the zoom, where exactly you're looking at the data. So the transition that I showed before would have been the example of the Box-Cox transformation. We're changing the data so that it is a different transformation. Whereas the view would be my zooming in on my time series plot. I'm not changing the data in any way. I'm just focusing on a different window within the plot. And you can combine as many of these together as you like. The rest of them are more of an extension of these or added bonuses. So you have this concept of shadows, which allow you to see a little bit of the history, a little bit of the previous frames in your plot. Entrances and exits. So say if a box plot suddenly doesn't have any data for this current transition or the next state of the plot, how will that appear or disappear? Will it fade in? Will it grow from nothing? These entrances and exits describe how we add or remove geoms from the plot. And lastly, easing, which describes how smoothly or in what pattern the geometries merge into each other or move around. And there's some nice visualizations of the different easings that we'll see at the end. Okay, I think it's well and truly time to create our first ggplot animation using Gganimate. Feel free to open up R. We'll go through this pretty slowly so you can try this out for yourself. I've got this side-by-side set up so you can see the code and the output. If you simply run ggplot with the dataset economics, you get a blank plot. We haven't set up any mappings yet. But if we add on the next slide, the aesthetics, this is mapping date onto the x-axis, which you can see down here, and unemployment on the y-axis. Still a static plot. Next, I add on a line, and here we get our classic time series plot. So you can see a few peaks, a bit of history happening here. And recently, well, at least for this data set, up until 2015, the unemployment has been going down. I imagine if the data was updated, it would be looking different. Okay, now here's the one you might want to try out for yourself. So with that static ggplot time plot that you would have seen before, or probably would be able to create yourself, the only thing we need to do to make it animated is add in the transition for revealing new information across time, across my date. So as I mentioned, transitions are used to modify the data. Here, my data is currently a slice, you can think of the data. We start with a small slice and then we reveal more of the data as the date increases. So yeah, just one line of code. Thomas's work with the Gganimate package is seriously magic. Being able to use the grammar, some way of describing the animation, is a really powerful tool. Okay, and a couple of more general questions for you. Is this a good use of animation? What do we think of this type of animation? If we think back to the reasons to use animation and the common problems that I see in animation, what do we think of this? Yeah, it's a bit slow. I definitely agree that it's pretty boring to look at. And that's the main thing I was looking for. This animation doesn't really provide us any new information. Now, even though we're not changing the data in any way, we can still provide more information I want to compare this plot that we have here with one of the plots I saw on the subreddit. Let me find it. This one here. So this is unemployment again in the United States. What's different between how this person visualized the data and how I've visualized the data? Okay, so keep in mind what's happening here. I'll flip back again to the slides. I'll just finish this animation one more time. Okay, so a shock, and then I go back to what I have. It's a bit slower, a bit more boring. So I think you're right there. It has a surprising effect, but why does it have a surprise effect? So the main difference here is while the transition is still occurring, we're growing the time series. Here we've got a static view, meaning the view of our plot, the axis, never changes. Whereas in this plot, the view is following the data. You see the axis is changing to grow as needed. And then right at the end, when unemployment shoots up, it's a sudden shock. And all the data changes. And what I also like here is that it stops at the end for a little bit, so you can actually take in what you've just seen and look at the full data set. So there's two things that this one is lacking. Let's bring this into R actually, and see if we can improve on this. Hold on, I'll need to open up R. Let me head back to the main screen. Okay, I'm in the wrong project, but that will do. So here we go in R. We have our code that I just took from the slides, which is going to reveal my unemployment over time. And if you just copy this code, it'll automatically start rendering the plot and it will show in the viewer. So this can take some time and there's some options that we can set to speed this up. But what I will do here is just start playing around with the different zoom options, the different view options. So remember, a transition is used to change the data in some way, or hide the data, or reveal the data. The view is used to change what we see on the plot, the different zoom of the data. And what we're looking for here is view follow. So view follow will follow the scope of the data. I can make the text bigger again. Okay, so currently here, this plot doesn't follow the code, follow the data. So we've got much larger y-axes than we need to currently show this data. If instead we follow it, it will grow as needed to match the data. Okay, it's going to take a bit too long to show this animation live, and because I'm also running my recording software. But do try this one out for yourself. I'll copy this in the chat so you can try it out, and maybe I'll get back to it. You'll probably be able to animate this faster than me because I'm currently rendering as well in order to show me on top of R. Okay, I'll come back to this code once I've got the animation running. So certainly I don't think this is a good use of animation unless we add the following functionality. The only thing that I would use this type of plot for is kind of teaching my students what a random walk is. If this is stock market data, for example, even though it looks like it's going up for a continued period of time, you really don't know what's going to happen next. So if you have the students watch what this line right at the end, and then have them try and continuously guess what's going to happen next, you'll find that they get it wrong more often than not. But it doesn't really add any more information to your data. So, like we discussed, it can be improved by adding in different zooms, different views to the data. Here's the faceting example that I alluded to before. Has anyone seen the Datasaurus dozen before? A Datasaurus dozen isn't actually 12, it's 13 plots, and they have the same statistical features. So all of these plots that you see on the right, all these data sets have the same mean, they have the same standard deviation, and they have the same Pearson's correlation. And it's really an example of why you should visualize your data, because it might reveal hidden surprises, like this dino. So I've got two approaches to looking at this data set. The first being just faceting it and producing a static plot. The second of which is animating. So if we go over to the next slide, instead of faceting, we can use a transition to transition between each of these facets. So remember, my state variable that describes each facet here is the dataset. You can copy this code and try it out for yourself. I think you'll need to load in the Datasaurus dozen package that I've neglected to put in here. So you really only needed one line of code here, but I've added two. There's a slight bug in Gganimate at the moment for the title. But the main thing we're adding here is transition states. So transition states, unlike transition reveal, isn't revealing new information. It's going to animate between several completely separate states. So if you've got box plots for one group, it might animate those box plots to represent a different group and then change the box plots around. In this case, it's showing a scatter plot and it's animating between each of the separate facets. And sometime soon, we'll see the dinosaur pop up. This label here is, there it is, there's the dino. This label here is trying to, unsuccessfully at the moment, currently display the closest state. So what does this current plot look most like? But there's some overplotting problem, a bug at the moment. Okay, I probably should have put a poll for this one actually. What do we think about this use of animation? Do we prefer to see this animation or the facets in the previous slide? It is more entertaining to see all the dots move around, I won't lie. It is a bit like a cartoon. Not really sure what's going to happen next with the dots. Personally, I think this is hiding too much information. I think it's taking a lot longer for me to find that there's a dinosaur in this data compared to just looking at the overall facets. So far I've given you two examples, both of which I think are not very good applications of animations, but we'll see some good ones later. Okay, so that was a bit of a taster for the different functionalities, the different grammars that you might use in the grammar of animation. Now we're going to play around, go in depth for all the different things that you can do with this grammar. Now here's the boring slide. But I won't read through it all, but these are all of the different transitions that you can use. So far we've played around with transition reveal and transition states. Some important ones for me personally is transition time. I think this is one of the, at least looking at the community animations that we saw before, time series transitions are the most commonly used, I find. So transition time, just like transition states, will move between different geoms, move geoms around, but it will do the pacing, the time between each move, relative to the amount of time between each one. So whereas states each animation moves at a constant rate, transition time will match the amount of time between those two states. So if it took 2 years to go to one, it'll be slower than the next stage that only took 1 year. I also use transition layers a little often as well. This will add new layers or remove layers from a plot. This is nice if you wanted to add temporarily, like a geom smooth, to show what the model would look like through the data, but you wanted to alternate between it. So you wanted to show the model and then hide the model. So I've got a bit of a quiz for you. You can flip back to this transitions reference. This will be useful for when you make your own plots to kind of identify what transition you prefer to use. But we've got a bit of a quiz. So I'll launch the poll. Here is an animation. Which transition have I used to create this animation? I hope as for the question, what's a good example for transition layers? I hope we're addressing it just before. Okay, I'll switch my windows around so we can see the poll again. Okay, here's the poll results that I'm seeing come in. Looks like about half of you have decided. And I think you've got it. So let's go over to the next one. This is indeed transition layers. So you can see we're adding on, first of all, a line for the entire data set, and then for each of the gear ratios, the amount of gears in the car, we're adding a separate model, a separate smoothing equation on top of the plot. All right, you can, of course, go to the next slide if you wanted to cheat and see exactly what's going on. This one's a little bit trickier, so I'm going to end the poll now and see if we can get transitions plot B going. Okay, so which of these is the transition that we see here? I promise you that this one was tricky, and it certainly is. And I'm glad to see that nobody is cheated, because this is actually a transition manual. This is a really tricky one. It doesn't look like anyone got that right, so I'm going to end the poll now. The reason for this is that there's no smooth animation between each of the frames. This is a manual transition because each and every frame of this animation has been programmed in myself. So that's why we get this very staggered step-by-step animation happening. It's a manual transition. There's a few reasons for why I wanted to show this with a manual transition. It is a bit labor intensive. The code for this is really gross. But I wanted to show that this is a moving average. So the data in the blue window is being averaged to get the red dot. And that's not something that really happens continuously. There's a specific point at each group of time values that we're combining together to get this calculation. Now, this is very similar to what you would have gotten with the old version of the Gganimate package. Remember how I mentioned that it had the frame aesthetic? You would be producing plots like this, where each frame is a group of rows in your dataset. that you're plotting separately. So the old version of Gganimate was very labor intensive, and we're very grateful to have the improved transition layers and all sorts of other transitions to use. All right, let's have a look at views. So we saw the view follow interactively. I couldn't get that example to run while I'm recording here, but hopefully you're able to try that out for yourself. There's a few other ones here. Most of them are pretty similar. There's only so many ways that you can move around the plot window. The two different ones is view step. While if you're doing both a view and a transition, the view won't change while the transition happens. So this will do it one after the other. Whereas view follow will continuously follow the data while it's transitioning. And then view zoom is very similar to view step. It just does more of a smooth zoom effect. It uses easing in order to zoom in. All right, so quiz time. What did I use to zoom in with this time series plot? I'll see if I can bring the poll up again. Let's end the poll. Put up a new one. Okay, let's see what you think. I can replay this animation for you by zooming in. This one's another tricky one, but it looks like most of you have the right idea. So see how we have this very slow build-up to the speed of the zoom, and then it reaches its speed and it slows down at the end? That is the effect of the view zoom option. But what I'm actually using here is view step manual. Sorry, is this step really? I thought it was zoom. Step and zoom are very similar, so it's hard to tell them apart. I think I could have used either, really. But the main part here is this is actually a manual transition because I haven't changed the data at all. So most view options, unless they're manual, will follow around the transitions, the change in the data. A manual change to the view will keep the data wherever it was, and that's why we can see the data right at the edge of the plots. Okay, last one for the views. Let's ask another poll. This dancing around dots. First of all, it's a very terrible graph. I can't see much of what's going on down here. But what type of zoom are we doing here? What kind of view? These view ones are really hard to identify because they are so similar. Okay, it looks like most people are not choosing the manual options this time. That's good to see. It is not a manual view in this case. Okay, I think that's most people that will respond. It is not actually view step, it's view follow. So the reason why it's view follow here is because while the transition is happening, it's simultaneously updating the view. So both the view and the transition are happening at the same time. If we instead, and you can, I could probably get the code up for you to try it out. If instead we used view step, it would first transition, and then it would rezoom in to the updated data. So do it in multiple steps rather than at the same time. Okay, I think this last one's a bit easier to see. So shadows show you a little bit of history between the animations so that you can see what happened in the previous frames. So there's only a few to choose from this time. We've got shadow mark, which will produce permanent marks on the background of the image. We've got a trail, which kind of leaves some points behind. And wake, which diminishes the shadow over time. So it's like got a little tadpole tail. I'll bring up the final set of polls. What do we think? What kind of shadow is being used as we dance between the sepal and petal links here? Okay, we're evenly matched. We can go back to the definitions if you like. It can take a bit of time to figure these out, and when you apply it to your own data set, it is really just trying and seeing what works best for your data until you get familiar with what you want to produce. I probably shouldn't be showing the poll results as they're coming in because I think that might be biasing some people, but this is actually a shadow wake. You can see very small tails that are getting smaller as it moves around. So it leaves like a tadpole tail, it's leaving a wake behind. So if we go back to the definitions, a shadow wake has a small shadow diminishing in size over time. So we'll just see a small tail to the dots. Okay, last one. We have this terrible time series plot, animation. It's like the spaghetti plot that I was talking about before. Okay. I'm not going to bias the results. We don't get to watch them come in. We'll reveal it at the end. We've all probably seen it, but it was neck and neck. All right, I think that's most of the responses in, and I think you got it right this time. So shadow mark, it's leaving a permanent mark each time the animation reaches its destination. Each time the animation reaches its state, it leaves a permanent mark on the screen. So well done. Okay, here's some extra bits. We're not going to see much examples of this because personally I don't use the entrances and exits very much. Often when I put something on the plot, it's staying around for every single animation part of the animation. So I don't really have things exiting the plot very often or needing to enter the plot. But if you do have that, then you've got some fun effects. Normally I would just use a fade, like a gentle fade in, have it appear. Or if you're using box plots, I'll have it grow from nothing. This is the fun part of the animations, all the customization options that you have. This is the easing. So how do we animate one point to go to another? And there's a really nice website down here that visualizes these controls. So these are all the options that you have for easing in Gganimate. And if you can click on any of them really, maybe ease in and out sign, you can see this dot next to the plot, if it was there, kind of starts slow, speeds up, and then slows down at the end. So that's the easing in and easing out using a sine wave. And you've got these buttons off to the side so you can visualize that. So the linear function is if it occurred all at the same rate, whereas the current function ease in and out sine will start slow, speed up, and slow down at the end. And that feels a lot more natural to me because in nature, things don't go at the faster speed or the constant speed. They always speed up and then slow down. So having these easing effects makes your visualization, your animation more natural. You can also get some really silly ones. If I go back, you can have some like elastic effects. So it kind of bounces around a little bit and then zooms out, and then it zooms in and it kind of bounces around. It looks like an elastic band. Okay, I've just been neglecting the chat. It worked quite a bit. You've worked quite a bit with motion graphics. You probably know far more about the easing effects than I do. But I'm really impressed. I agree with you there. Gganimate, thinking about animation in this way taking into account all of the motion effects and all the easing is a really neat functionality to have. All right, let's do a demo. So I hope most of you have seen this visualization before. The Gapminder example is a very famous data visualization. But essentially, this is showing lifespan of countries. So each dot is a country. And on the x-axis is the GDP, the income of the country. And you can see as income increases, lifespan is also increasing. So this is a very famous very famous animated graphic, and we're going to create that for ourselves using Gganimate. There's a question in chat, any links, code, or help to get animations onto Twitter? I think if you just save it as a GIF, then you can drag and drop it in. I haven't put any animations on Twitter for a while, but that's how I used to do it. So I think you can just drag GIFs on without problems. So at the end, I'll talk about the different rendering options that you have for animations. So you can choose to produce a GIF or a video or anything you need, or any renderer that's available. So the Gapminder dataset can be found in the Gapminder package. So if you load in Gapminder and then use Gapminder as a dataset, then we can start making a plot. It's already in a long format, so it's ready to use with ggplot. So I'm going to put on the x-axis the GDP per capita, the y-axis the life expectancy, and one thing that I didn't mention in the classic Gapminder animated visualization is that the size of the countries is represented, size of the dots represents the population of the country. And here I've colored by country. I think this is actually misnamed. It's more like the region of the country. And I'm using a scatter plot here. Now, one thing that's necessary to really see the structure of this data is to log scale the GDP. Otherwise, the very wealthy countries will blow most of the countries out of scale, out of proportion. And then I've just used a nicer discrete color scale and made the larger dots, the higher population countries, larger. So I've changed the possible range, the possible scale for the population size to be a little bit more obvious in the plot, because there was also a lot of very small countries that you couldn't see. Adding on some labels, just static labels. This is all standard ggplot code. We haven't added any animations here yet. There's a question in the chat about transition reveal and the options that are available for that. There's one option that you pointed out there, keep last, is an interesting one that is worth mentioning, but we'll talk about the other ones when you're working on your animations at the end. This keep last, see how it's stuck on this last page on this animation so we can see what's happening? So the keep last option in transition reveal allows you to hold on to the entire plot for a little bit longer rather than immediately removing it. So I think it's a number in seconds that this should be kept for. Okay, so let's take this scatterplot, this static scatterplot, and add in some animation. So the classic Gapminder example is animating this data over time. So thinking about the transitions that are available and the views and all the other options we had, what would be needed in order to transition this scatterplot over time? Sneak peek. So the naming convention here is pretty straightforward. It's nice to have a grammar. We're doing a transition because we're changing the data as we go, and we want to transition over some time variable. Just in case there was some missing data for some years, it will allow the the points to accurately represent the movement in time. So transitioning over the year, and I've set the label also as an extra so that we can see the text for the current year updating. Otherwise, we wouldn't know what year it currently is in the plot. And this is the main part of the Gapminder animation, written with just one line of Gganimate code, transitioning with time. The rest of it is ggplot, a lot of scaling, a lot of other options that aren't strictly necessary. So there's really not much to learn in order to make some animations. Okay, so now I've added in another view just to mix things up a little bit. This isn't what the classical example is, and there's good reason for that. By adding the view, did we improve the plot? Did we add information or add value? I haven't got a poll for this, but you can just put your thoughts in the chat. So last time we used view follow was for this type of plot, and we found it really useful to get a better sense of scale when the surprising event at the end happened. And this time, are we getting the same effect? Are we getting benefit from using this view?
Yes.
We are? So what benefit do you think you're getting from looking at this animated view? And if anyone else has a different opinion, feel free to put it in the chat. We'll have a little discussion. We've got heaps of time. The change over time is more obvious. Yeah, I can see that. What else could we use to make the change over time more obvious? Thinking about the different animation tools that we have in our grammar. We've got transitions, views, entrances, exits, shadows. I've excluded easing here because that's more of a configuration rather than an animation effect. Oops. Let's go back to that page. So they've got view follow. I think it certainly zooms in the plot more than it otherwise would, so that we can see more fine detail in what's happening relative to each country. But I think this is not actually an improvement to the plot, personally. It depends on each person, really. But I think it's a bit disorienting to have the axes move around so much when it doesn't need to move. We already get a sense of scale with a static axis. So if we were able to see the countries grow without moving the axes, I think it would be clearer. And you'll notice actually I've fixed the y-axis. Otherwise it would be completely disorienting to have it moving up and down as well. Okay, how about now? Does this help visualize the change over time of these countries? Can we identify the countries, or at least the blobs, we haven't named the countries, that are moving very quickly? So this is, of course, using a shadow to add a little bit more history. It does look a little bit like a petri dish, doesn't it? So I think that a big takeaway here is to have some fun with your data, have some fun with your visualizations, and try and make something interesting with your plots, with your animations. Because I guarantee if you did a couple of facets here and tried to share it with some other people that don't know how to interpret plots, versus kind of explaining or telling the story like is done in Hans Rosling's work here, showing this animation and talking through it is a really powerful storytelling tool. Can you add that stop at the end argument? For transition time, I'm not sure. Let's have a look together. I think all time transitions can. We'll load in Gganimate. It doesn't look like you can here, but I think there's a more general option for the animate function, which allows you to set the end pause. This is what I was looking for. So no matter what transitions you use, it is an option for transition reveal because it is so necessary to have a little bit of a pause at the end. But even if you're using any transitions or any animations, on the animating step, you can specify how long you wait at the end of the animation before starting it again by setting the end pause option. So even though if I run this code, it'll automatically run the plot, we can save this plot, like anything in ggplot, and then animate it separately, which gives you more options, like end pause for 1 second. All right, another question that I've seen, how do you save the plots? That's a good question that I have coming up now. Let's skip ahead to that. So exporting animations, just like we have the animate function that I just talked about, we have another function called animsave, and this works exactly like ggsave. So this allows you to save to a specific file. We want to save it as a GIF here, for example. So we might want to save my animation, and you can specify all sorts of options. How long to wait before starting, the size of the animation, the dots per inch, the resolution, all sorts of stuff. But the main part here is thinking about the output type. So GIFs are pretty nice to share around, but they can be a relatively large file size. Personally, I prefer to export my animations as a video file. It helps with the compression a little bit more, so it doesn't take as much bandwidth, as much space. So here are the various renderers that you can use to combine the frames of your animation into a single file, like a GIF or a video. And I would usually use FFmpeg renderer or AV renderer in order to create a MP4 or some other video file. But you can also dump them to a file if you wanted to have each frame separately and combine them yourself in some other software. One thing I would note, the default here for producing a GIF is far better than the Magic renderer. Magic is a very powerful tool, but it's a very general purpose tool. GIFski is specifically made for making GIFs, which makes it super fast at rendering your GIF. Would you please write some code using FFmpeg? Yep. Let's actually go into R, because my time series zoom animation that I was showing you before actually used FFmpeg. Let me move over to the code for that. Okay, so here is my code for zooming in on that time series plot. I have my data set here, and I'm doing time on the x-axis, demand on the y-axis. I'll go back on the slides because we're pretty much at the end, just to compare this. And the last slide here is to make your own animation, so that's what we'll do after this. But let me go back to the start somewhere. Yeah, this one here, where I've zoomed in, you'll see the details a little fuzzy because I really cranked up the compression. But this zoom in animation is a FFmpeg render. And you can see I was transitioning states as well, but this isn't really required. The main thing here is that I'm changing the view manually, which is also the same as view zoom manual in this case, or roughly equivalent. And I'm zooming in on a particular time point. So the 1st of July up until the 30th of July, where I started at the whole data set. So start of 2012 to the end of 2014, zooming in to July 2013. And I've also calculated the y coordinates here too. But the important part here is the anim save. I've saved this as a MP4 for this given plot that I've saved as P, and I've decided to set the FFmpeg renderer as the renderer of choice. So this will generate the MP4 with the appropriate width and height, the formatting for the FFmpeg, anything I needed. If you wanted a GIF, you can just leave out the renderer. The default is really good for GIFs. Another question, could it be inserted into an R Markdown document with HTML output? It sure can, and that's what I've done for most of these plots. So if I scroll down a little bit further, maybe this one here, here I'm following around the box-cox transformation, and I've just passed it into animate here. Alternatively, you could do print, and it will have the same effect, but I wanted to make it a little bit more specific for the starting and ending pauses. Okay, another question, when combined with Shiny, can it be hosted on the Shiny server? Yes and no. Usually I would want to pre-compute my animations for a presentation or a class. You certainly can do animations within Shiny and have the parameters change how the animation works. But the main issue that I could see here is that it takes a lot of computing resources in order to combine all of the files and generate each of the plots to make that animation. So the end user might not be having a very good experience when they click animate and it takes 20 seconds for the animation to get back. It's much better to use the interactive elements there, maybe a JavaScript plotting library, which will not need to render it to a file, and it will just animate it directly with JavaScript. I do have some examples of that right at the end. So we talked about all the different transitions. We had some quizzes. We talked about Gapminder. Okay, and here it's your turn. I love this as a question and answer, so I'm happy to keep going here. The your turn that I had in mind was for you to take that plot that I asked you to come along with and try out some transitions, add a couple of views, and see how you can look at different aspects of the data set to tell a different data story using animation. And if you didn't bring a plot, you can try out the Palmer Penguins dataset. There's some really nice animations you can do with that, or continue working on the Gapminder dataset to change the aesthetics, like the easing rate and so on. And if you're doing the Gapminder, it's a bit easier because you've got a bunch of code to get you started. So have a go with that. I'm going to continue answering some questions. For the Shiny server, a good alternative is Plotly. This is a JavaScript plotting library that has a Plotly package for R that's quite good. And you can see here I've added in a slider here for the Datasaurus Dozen example, and it gives you a play option, so you can animate between them. So if you wanted to do this in a Shiny app, you can have this data being a dynamic input, or you can have the possible choices to animate between being an input value as well. The main difference here is it doesn't need to pre-render the animation because it's calculated live in the browser using JavaScript. There's a bunch of other more powerful libraries as well here, like D3. High charts is used a lot for time series as well, I think. Most of these libraries you'll find are designed as interactive graphics libraries where people can zoom in themselves. If we go back to the previous Plotly example, we can zoom in on a certain part of the plot manually. So it's really designed for interactive exploration. But on the continuum of engagement, if you can do interactivity, then you can also do animation. So Gganimate's quite special in order to have a purpose-built animation library, and that's why you also get a bunch of other features like being able to control the easing rate, which you don't see in a lot of the other more general packages for interactive graphics. Okay, I'm not quite sure I understand your question. What about those transitions with data on a map into, for example, a bar plot? Are you talking about how to do the chasing bar plots that we saw on the web? Like this one here? With all the different y-axes moving around? There was a better example further down, this one here. I actually don't know how to do these types of plots in Gganimate. It's a little bit unusual for the grammar of graphics to have the coordinate system changing. So I'm sure there's a way, I'm sure someone's found a way. Maybe if Mikhail was here, the Gganimate expert with ggpacman, he would probably know. But this does seem like it's against the grammar of graphics a little bit to change the order dynamically over time. Oh, sometimes you see a map changing into a bar chart. So maybe you've got countries that are different colors or different sizes, and then they morph into a different type of graph. Yes, that is possible with Gganimate. I don't have an example on hand, but maybe we can find one in the wiki. So I know this is possible because Thomas has written a whole package to make that possible. The package here that makes it possible is called transform R, and that's transforming arbitrary polygons into other polygons. Let's see if there's an example here. Doesn't look like it. It might be in the transform R package. So you can see a similar motivation. You're making a star into a circle. That could be the same as transforming a map into a scatter point. Or in this case, splitting up the triangle, the star into multiple dots. So I know it's possible. I don't know of an example on hand other than that Twitter post. Do you have the code available for this? Be nice to have a look at it. Is this made using Gganimate? So this is part of the problem with GIFs, I think. It can take a little bit of time to load in, especially if you've got a very detailed GIF like this one is. And that's why I generally prefer a video output, MP4 output. But that's very nice. If you could share this, the code for this in the chat, maybe you've got a GitHub or something, that would be awesome. Okay, that's all of the content that I had, but I'm happy for everyone to keep working on some animations and I'll keep answering some questions. Other than that, thanks for coming along and listening to the chats. I think we've got time allocated up until 6, is that right? Or my 6, another 30 minutes.
Thank you so much for this great workshop. So it was so awesome. So please, dear participants, don't hesitate to to leave your questions in the chat. You are welcome. Thank you for attending.
Yeah, thank you for coming along. It's been a lot of fun. It's really nice to have such engaging audience. Yes, good point. So the code and the slides. So I've got a link down here to review the slides. This is just a link to the slides, but all of this is open source as well. Let me get the link for this. So you can find this on my GitHub. One package per meetup. You can see all the times when I've been working on this. So here you can find the index.rmd file, which contains all of the animations, and I've tried to include all of the code needed for the contents of the slides today, including the quiz section as well. So you can look at how those terrible animations, but good examples of the functionality, how you do them. So for example, the views here, we have the transition states with the view follow example. I've just put the link to GitHub in the chat. It might take a minute to come through. Should be pretty quick though.
And we'll share with you the recording video soon. So it will be shared on our YouTube channel. An email will be sent to you. I'll send you some links. So don't hesitate to share with us your feedback also. That will allow us to improve the quality of the workshops. And also you are welcome to join our meetup group. So to be able to be notified about our next meetups. Thank you, Iman, for attending. Okay, I think you are done with the questions.
Yes, wonderful.
Yeah, wonderful.
Time for a big sleep in.
Yeah, it's 10 a.m., 9 a.m. in Tunisia already. PM, sorry.
9 p.m.
Yes, PM, I would say. Okay, thank you. Goodbye, all. Thanks again,
Before
Mitchell.
we end, there's GitHub links not coming through. So you can find my GitHub account on the slides. So I think I had it here on the second slide. If the link isn't coming through, if you just go to this GitHub handle, oops, sorry. Yes, I am sharing screen. If you go to this GitHub handle, you should be able to find through my recent commits the work that I've been doing on these slides. But thank you everyone for coming along. I hope you've enjoyed, and I hope you've learned something about animation.
Thank you. Goodbye.
This is Pierre. I just want to say it was a very good presentation. Really enjoyed it. Pierre Du Bois from Gary, Indiana, US.
Thank you. That's
Fantastic.
great.
Thank you so much. Yeah. Is it early for you?
It's only 2:39 in the afternoon here. I'm on Central Time, so just outside
much
Chicago.
More reasonable.
Yeah.
Sucks to be in Australia sometimes when you're working on international calls.
You did great. I'll put my video on. You did there we go. Yeah, you did great. So I really enjoyed it. Thank you.
Thank you for coming along.
Thank you. Bye.